Hello everyone, welcome to another lesson. On this particular video lesson, we're doing problems 19, 20, and 21, 22 from our notes from 5.9 day 1. We're talking about imaginary numbers, and for these last ones, we're simplifying complex or imaginary numbers when there's a fraction, or another name for a fraction, I guess, is a division problem or a quotient. So we can read this one as 4 minus I over 5I, if we were to consider it as a fraction, or if it's a division problem, 4 minus I divided by 5I. Either way, the same result. So what we do here is kind of think of it when we had, let's say we had x plus 4 divided by the square root of 3. What did you guys notice about this problem? Hopefully you saw, oofta, there is a radical in the denominator. So what we need to do is we need to rationalize the denominator. Same thing with complex numbers. One thing that cannot happen mathematically is you cannot end up with an answer with an imaginary number in the bottom. That is mathematically against the rules. So you have to rationalize the denominator, making it a real number. So this I cannot be here. We have to get rid of this I. Now remember, how do we go from the imaginary world to the real world? We said that I squared equals a -1. Here's imaginary, and here is real. So as long as we can get an I squared, we can change that to a real number of a -1. So if I want to get my denominator to be a real number and not imaginary, I need to somehow get an I squared in the bottom. So how do I get an I squared? Well, quite simply, I would multiply the bottom by I, because 5I times I is 5I squared. What you do to the bottom, you must do to the top. So if I multiply the bottom by I have to multiply the top by I as well. So now we have this. We still have a fraction. In the denominator, 5I times I is 5I squared. In the numerator, here's a binomial, so you have to distribute. I times 4 is 4I, and I times a -I is a -I squared. So now, class, every time you see an I squared, exchange that with a -1. So we have 4I minus I squared, which is a -1, divided by 5 times a -1. So as you can see, we're going to have 4I minus a -1, which is +1. So it's 4I plus 1 divided by 5 times a -1, which is a -5. This would be my answer if there was no such thing as standard form. But class, what is standard form again? Standard form is where the numbers come first and the i's come second. So my answer, just changed the 1 and the 4i around. 1 plus 4i, that number divided by a -5. And this is our answer. Class, once again, the reason why we do this is because we cannot have i's in the denominator. This I right here cannot happen. You can have i's in the numerator, just like you can have radicals in the numerator, but you cannot have i's in the denominator. So whenever you see an I in the denominator, you have to rationalize the denominator. So with that being said, you guys now try number 20. And there is some pictures for your enjoyment of my son. What a cutie, huh? Anyway, you guys try number 20 on your own. Pause the video. 2 plus I divided by a -3i. Unpausing the video, hopefully you guys did the same thing as the last one where you multiplied both top and bottom by I. Once you did that, you got this 2I and this I squared, and you should have gotten this -3I squared. After that, every I squared you should have changed to a -1. So I squared is a -1, 2 times I is 2I, and a -3 times I squared is a +3. Or -3 times a -1 is a +3. So this should have been your answer. A -1 plus 2I divided by 3. All right, now that you have that one down, The first two, 19 and 20, were monomials in the denominator. Now 21 and 22 are slightly different. They are binomials. So when it's a binomial, what did you do when you had, let's say, 5 divided by the square root of x minus 3? When you had a binomial with a radical, how did you get rid of that? What you did was you multiplied by the conjugate. Square root of x plus 3. You did that to the bottom. You did that to the top. The square root of x plus 3. One thing that's kind of nice, we do the exact same process with imaginary numbers. When we do that, the i's are going to cancel out. So we're going to have 3 plus 2i. To get rid of this I in the denominator, we have to multiply it by the conjugate. 3 minus 2i. What you do to the bottom, you also have to do to the top. 3 minus 2i. So class, I want to show you one time very slowly how those cancel out, and the next time you can do it very, very quickly. So for the bottom here, for the denominator, we're dealing with this part right here. We're going to FOIL this. 3 times 3 is 9. That's the first. Outside, 3 times a negative 2i is a negative 6i. Now we have the inside terms. 2i times 3 is a positive 6i. And then our last, 2i times a negative 2i is a negative 4i squared. So what always happens with conjugates? The middle two terms always, always, always cancel out. A negative 6i plus 6i is 0i. That is gone. And now, what is I squared the same thing as? A negative 1. So what do you have in your denominator? 9 and a negative 4 times a negative 1 is a positive 4. What just happened to your denominator? It became real, not imaginary. 9 plus 4 is 13. So our denominator is 13. Once again, we got that because when we FOILed, the middle two terms canceled out. This I squared became a negative 1, and then we multiplied that by this negative 4. A negative times negative is a positive, and 9 plus 4 is 13. And I promise you, class, this wasn't coincidence. Every single time that you multiply an imaginary binomial by its conjugate, you're going to get a real number. That is a promise from Mr. Berge. That will happen every single time. So if ever you see a binomial in the denominator and one of them is imaginary, multiply by the conjugate and the imaginary numbers will disappear. So now we just have to simplify the top by distributing. 5i times 3 is 15i, and 5i times a negative 2i is a negative 10i squared. Let's change that I squared into a negative 1. So it's 15i minus 10 times a negative 1. That over 13. And then a negative 10 times a negative 1 is a positive 10. And the numbers always come first, and the i's come second. So it's a positive 10 plus 15i divided by 13. 10 plus 15i divided by 13 is the answer to 21. So now that I've done 21, you guys try number 22 on your own. Remember, you're going to multiply by the complex conjugate. Look at Matthew. Look at that smile. Good stuff, right? All right. So as we multiply this, actually first pause the video, try this one on your own. Once you have tried this one on your own, you're going to multiply both top and bottom by 6 plus 5i, because that is multiplying by the conjugate. So the middle two terms are going to cancel out, class, so I'm not even going to worry about you writing that. You could just write the first times the first and the last times the last, because the outside and the inside are going to cancel out. Where are we at here? There we are. You could see the denominator. 6 times 6 is 36. A negative 5i times a positive 5i is a negative 25i squared. So that's how we got the denominator. The middle two terms will always cancel out. So now the numerator, you have a binomial times a binomial. Let's FOIL it. 4 times 6 is 24. A positive 20i minus 12i, positive 20i minus 12i, and here you have a negative 10i squared. So now we're going to combine like terms, and we're going to change every I squared to a negative 1. So that's how we got 24, 8i right here, and a positive 10, because the negative 10 times I squared, which is a negative 1, is this positive 10. In the same way, a negative 25 times a negative 1 is going to be a positive 25. So now simplifying it, our answer, 34 plus 8i. 34 plus 8i divided by 61. So that is how you do those ones. We're rationalizing the denominator by multiplying by the complex conjugate. So for our assignment, make sure you let me know if you have any questions on these three objectives. It is objectives 67, 68, 69, and 70.